In this video, we'll discuss about the next topic, that is trigonometric equations. Okay, now what we mean by trigonometric equations, and there are two types of problems what you can expect from this one. Alright, now the meaning of a trigonometric equation. Now, till last year, you have come across quadratic and linear equations, correct? Now, when we talk about a linear equation, now remember the degree is 1 and quadratic the degree is 2. Now, what we are discussing and what we are talking about in this particular topic is an equation which is, the variables are trigonometric functions. Like how you had x, y and x square, y square types. Here you are going to have sine, cos, tan, theta, whatever might be the trigonometric function. But majority are these three, sine, cos and tan. You rarely get cosecant, secant and cot. Because when you get these, you can just invert it and you can get in terms of sine, cos and tan. Fair enough? So, this particular topic, we are going to understand how do we solve a trigonometric equation. Now that you have understood, it's very similar to the equations what you have learnt before. Like for example, if you consider any linear equation, say you have 3x plus 6 is equal to 0. You know how to solve it. Likewise, when we talk about a trigonometric equation, we are going to have a value something like 2 sine theta plus 1 is equal to 0. What is the value of theta, or what are the values of theta? Something like this. So, since this is the type of questions we are dealing with, the first part of the problem or first topic within this one is going to be based on finding the principal values of trigonometric functions. Now, when we say principal values, what exactly we mean by a principal value? Now, to understand this, we'll go with the graph of a trigonometric function. All right. Now, let's start with the graph of a very simple sine function. Now, we have graph of all 6 trigonometric functions. We have discussed this in the previous videos, one of the previous videos. Please go through that again if you have any doubts in the graph. Now, we'll start with very basic, that is the sine function. Now, here, let's assume that, see, you're going to have a straight line like this. Within this, we are going to have a sine function. Okay, let's assume this is a sine function. Now we have a maximum value of 1 and the least value is -1 with 0, correct? Now the angle within this particular function. So here what we can do, so if you take this is going to be pi by 2, this is pi, this is 3 pi by 2 and this is 2 pi. And you know that the rest of the things, it's just going to repeat itself, correct? It's a recurring function. Now, the values what we have here, this is quite important. Suppose, say, we are looking at a value of half. Let's assume. That means here, we'll look at a value of half. This value is half. Now, when you take this, within the first and second quadrant, there are two values, isn't it? Now, there are two values for which sine theta can become half. That means here, suppose if we say that sine theta is equal to half. Okay. Now, in the first quadrant, we know what is the value. So, theta can be equal to pi by 6. Pi by 6, it's in the first quadrant. Now, if you need to know the value in the second quadrant, like what it will be. So, what we do is we can do theta is equal to pi minus pi by 6. The reason is sine of pi minus theta is the same as sine theta, isn't it? That's why we take it as pi minus pi by 6. Pi minus pi by 6 is how much? 5 pi by 6. So what we can conclude is, if sine theta is equal to pi by 6, then theta can take two values. Okay, so theta will be either pi by 6 or it can be 5 pi by 6. 5 pi by 6. So these are the two values for which theta, so two values of theta for which sine theta will be equal to half. Now the values what we got here, this value, these two values, these two are what we call as principal values. Principal values for a trigonometric function. Now, for different things and depending on what the value is, the principal values can also change. Okay, let's take another example with the negative sign and we'll look into that. All right. Suppose let's say we have cos theta is equal to minus 1 by root 2. Now, cosine is negative in which two quadrants? The third and the second quadrant, correct? Second and third quadrant, cosine is negative. So, what we can do here, again, you can start with the graph, which is much easier approach, but it will take some time. The second approach is you just know the sign convention, ASTC rule, which is positive in which quadrant. So, if you know that, that's well and good. Okay. Now, for what value you're going to get 1 by root 2, pi by 4, 45 pi by 4. So what we can do, it's a negative sign. So we know it's in second and third quadrant. Second quadrant is always given by pi minus theta. And third quadrant is always given by pi plus theta, correct? So in this case, what we can do and what we must do is, you know, for theta is equal to 45, cos theta will be 1 by root 2. So what we can do is, cos theta is equal to minus 1 by root 2, correct? So theta will be equal to pi minus pi by 4, or theta is pi plus pi by 4, isn't it? Now when you do pi minus pi by 4, you're going to get 3 pi by 4, and when you do this, you will get 5 pi by 4. So theta can take two values. So these two values are what we call as principal values. This is going to be 3 pi by 4, or this is going to be 5 pi by 4. Now for all trigonometric functions, we are going to have these principal values. Okay, like suppose if this is the value, what are the principal values? Generally, whenever or whatever the trigonometric function you take, the principal values we take from 0 to 2 pi. Because the reason is, after 2 pi, every trigonometric function is going to repeat, irrespective of what value or which trigonometric function you are going to consider. It's always going to repeat. So because of that reason, we consider only from 0 to 2 pi. Fair enough? So this is how we calculate the principal values for each and every trigonometric function. Now this is the basis of trigonometric equation. Because think about it, if you get an equation, you have to get a value for x, correct? Like for example, if I take x square is equal to 1, x is plus or minus 1. So you are going to get a value for the variable. Now trigonometric equation has trigonometric functions as the variable. So we need to get a value for the trigonometric function. In turn, we are going to get the value of the angle for which the trigonometric equation is going to get satisfied. So technically speaking, we are calculating the value of the angle theta, and that we can figure out with the help of these principal values. This is the whole point of solving a trigonometric equation. All right. Now, this is one way of calculating the principal values. Now, can we get a general formula for this? You know, suppose say if I say sine theta is equal to sine 30. So we can't always say that theta is equal to 30. Not all the time it's true. I mean, one case, yes, but not all the time. Suppose if you get sine theta is equal to 0, will you always say it is 0? No, it can be 180 also, 360 also, or any multiple of that, correct? That's why we need to have a general solution for a trigonometric function that we'll discuss in the next video.